Hi, welcome to 10.9, a question of resistance. So far we've talked about volts, which is the measure of the amount of energy in the electrons that pass through a current, through a circuit. And we've talked about current, which is the number of electrons that pass through. So volts is the amount of energy in the electrons, and current is the number of electrons. Alright. So, what we're going to talk about today is electrical resistance, which is a measure of how difficult it is for the electrons to pass through a circuit. Okay, and we're going to take out some fancy maths here. It's awfully complicated, you won't be able to understand it, I'm sure. Really all it is R, which is for resistance, and then we have V for voltage, and then I, which is for electric current in amperes, and that's really as simple as it is. Okay, and that's eventually measured in ohms. Okay, so let's do an example. So the torch. Remember the torch we did, a couple of videos ago. So the torch. Let's say the torch had 200 amperes, milliamps probably, more realistically. And it had a voltage drop of 3 volts. Alright, 3 volts. Good. So that means the resistance is volts, which is 3, over the milliamps, or well, that's measured in amps, so it's got to be 0.2. Alright, 200 divided by 1,000 is 0.2. And we end up getting 15, 3 divided by 0.2 is 15, and we have ohms, and we get to draw this funny little symbol here for ohms. Okay, so does that make sense? So this is how to calculate resistance. R equals V over I, where V equals volts, volt drop specifically. Alright, and I equals the current in amperes. Amperes. Okay. So, what are we looking at here? So, in 1827 or so, there was a German physicist by the name of Georg Simon Ohm. So, he discovered that the voltage drop and the current were proportional to each other in particular metal conductors. So that meant that if the voltage was tripled, the current was tripled. Or if the current was doubled, the voltage was doubled. And this became Ohm's law. Okay. Now, this is kind of represented in here. So what this is saying is if you have two volts here, and you double it to 4, okay, we'll go from, see, it's probably not very accurate there, let's just move that along down a bit, go from about 0.01234, 246 probably, and we've gone up to about 12 or so. Okay, so you can see that as you've doubled it, it's the amps has doubled. All right, and then as you triple it, 246, you can see it's gone up to 0.4, and you can see that as you double the volts, the amps double, and as you triple the volts, the amps also triple. So this is the relationship that we're looking for. It's a proportional relationship, alright? As the volts doubles, the amps double. And that's really as difficult as it gets. So the materials that obey this law, unfortunately not all materials obey the law, they're considered to be ohmic materials. So basically all metals and carbon are considered to be ohmic materials as long as the temperature is fairly constant, whereas a lot of other materials are not. All right. For example, the filament in a light globe is not ohmic for reasons we're not going to go into today. Alright, so what we're looking at here is a variable resistor. So we have a wire coming in here, and we've got a coil here, and the electricity, it passes through and then connects to here. So we can move this slide up and down here, and if we move it more towards this side, the electricity has to pass through more of this coil. Alright, so that means there's going to be more resistance. It has to travel through more more wire, and therefore it'll be more resistance. But if you move this slide all the way down here, it has less resistance to go through, so therefore more electricity would turn out. So this kind of variable resistor is used in volume buttons for radios and televisions and whatever else, or it used to be anyway. I think there's a lot more kind of electronic now, but this is the idea. So as you move the slide down here, it's less resistance, more electricity goes through, and the volume becomes louder. As you move the slider further up here, it's got more coil to go through, therefore it's more resistance, there's less electricity to get through, and the volume is softer. And this is just some cute photos of some resistors. So you can see wires in, wires out, and then the coils, or what and inside these kind of containers. And you can see that this one would be a low resistance, and this would be pretty heavy duty resistance. And they all have different symbols depending on the variable resistors, and which type of resistor you're talking about. Alright, so that's all good. What I'd like you to do is go through chapter 10.9, put the blue words into Quizlet, and answer questions 1 to 4. I'll see you in class.